Welcome, esteemed colleagues. Today, I invite you to explore the results of a two-part analytical simulation conducted within Google Colab, aimed at evaluating regulatory gaps and technical reliability in the domain of Metaverse cybersecurity. Let's begin with the upper panel, which presents the Python code implementing Stage 4 and Stage 5 of our study. In Stage 4, we conducted a keyword frequency analysis on a corpus of expert interviews and case studies. As you can see from the resulting data frame, we systematically extracted and quantified 6 key legal concepts: liability, jurisdiction, avatar, consent, fraud, and privacy across each document. This lexical mapping allows us to trace which legal vulnerabilities are most prominently discussed by practitioners and developers working at the frontier of virtual environments. Transitioning to Stage 5, the lower plot presents a comparative ROC curve analysis of 3 different authentication models used in immersive VR/AR systems: biometric authentication, traditional PIN codes, and multi-factor authentication, MFA. In this simulation, we generated similarity scores for both genuine users and imposters, using a Gaussian distribution to reflect real-world variability. Each method was evaluated across a range of thresholds, and their performance was measured in terms of the trade-off between the true positive rate, TPR, and false positive rate, FPR. Now, if we direct our attention to the plot itself, we see that the ROC curves for all 3 methods cluster tightly toward the top left corner, indicating strong performance. The PIN-based authentication, represented here in orange, achieves the highest overall accuracy with near-perfect separation of genuine versus imposter cases. The MFA model in green also performs robustly, offering an excellent balance of security and flexibility. Meanwhile, the biometric approach, though slightly more prone to false positives, still yields a TPR above 90%, suggesting that it remains viable when coupled with proper encryption and liveness detection. The diagonal dashed line represents random guessing. As all 3 curves lie well above it, we can confirm the discriminative power of these models in a simulated environment. This comparative analysis not only highlights the technical efficacy of each method, but also underscores the necessity of matching authentication strategies with appropriate legal safeguards, especially in jurisdictions lacking clear standards for biometric data governance. In summary, this experiment bridges legal linguistics and machine-driven simulations to provide a multi-dimensional perspective on digital identity assurance in the metaverse. It demonstrates how both semantic data and statistical modeling can inform policy recommendations for secure, ethically governed virtual ecosystems. Thank you for your attention. And now, let's proceed to interpret the policy implications of these results in the next session.